Here is a little workthrough of how to put your results into Excel and get a graph for the parachute experiment in grade 9, but it's also how you just generally do experiments in Excel to get results. First thing you're going to do is create your results table. You will almost always have trials 1, 2, 3, maybe 4, 5, 6. I'm just going to do 3. I'm going to do an average. This is your dependent variable, so we're going to merge these boxes. That's this symbol here, and we're going to write in it time to fall, and we measure time in seconds. And then this one is going to be our independent variable. Again, I'm going to merge them here, and that would be, let's say, size of, most people did height of drop. And we measure that height in meters. It looks a bit scruffy when it disappears out, so we're going to click on this ABC button that wraps the text. If you need to, you can make the box bigger. You can make this box bigger, however you see fit. Let's say you did heights of 1, 2, and 3 meters. You got times of 1.2, 1.3, and 1.7. And then you got, 2.4, 2.1, 2.8, and then 3.7, 3.8, and 3.9. Oh, hang on, actually, let's do one. Let's say you got 3.0. Annoyingly, Excel, if you put 0.0, will always convert it back to a single number. If you right-click on it, you can go to Format Cells, and then you want number, and with these were all 1 decimal place, it will then do that for you. For the averages, you will need to do that as well, because often the average will come out with a load of decimal points. You cannot give more decimal points in your average than you have in your results. If someone told you that their drive to school is 1 mile and another person said it was 2 miles and another person said it was 3 miles, we can't then say, the average is 2.0. The average is 2, because you don't know whether the first person meant 1 mile or 1.2 miles. You don't know. You assume they mean anywhere in the 0.5 to 1.5 range, and that they rounded. So you need to round correctly. To find the average on Excel, you go on to Insert, Formulas, and then normally the auto sum has got an average, but it'll pick up random boxes, so you need to select the boxes that you want and press enter. You can then drag the corner down to make it do the same for the ones below. And then that's our results table. I like it if we just make it a bit smarter with a bit of putting an edging around it. Maybe you want to put some slight coloration on it just to make the sections stand out. There we go. Oh. Maybe you're going to have the other ones in green, but you've got the top headings are all slightly darker to make them stand out from the lower headings, something like that. What we also want to do is a graph. So I tend to find the easiest way is to write the numbers again below, but write them, don't copy paste them or anything, or if you do, copy paste values only. There we go, and then you select that data, insert, you want this graph here, XY scatter, and then you want to add chart elements. You want a trend line that is linear, is most common, and you want to put labels on the axes, and you want to make sure you don't have a legend for a line graph, because there's only one line, so you don't need a legend. Make sure you name these correctly and give it a title. These are all then ready to be copy-pasted. You might even choose to put a bit of coloration on it or something just to make the graph look a bit nicer and more personalised. That is how we do it. What we also want then, we want to select the data, and we're going to right-click on it, and we're going to format the trend line, and we are going to display the equation and display the R squared value. The equation is helpful because it tells you the gradient, which is good for your conclusion. The R² value is to give you an idea of reliability. How repeatable are these results? How close are these dots to the line? You can see from this, these dots are really close to the line, which means they have an R² very, very close to 1.0, which would be like the dots are literally on the line. If the dots were all over the place, you'd have an R² of like 0. So this R² value allows you to comment numerically on the reliability of your results. If you don't understand what it is or how it works, you should definitely do some Googling. It is a very helpful tool for you in your analysis, your evaluation sections. These can then be copy-pasted or screenshot bits and put them in your work.